Greetings, coders. In this video, we are going to look again at breadth first search, except this time we're going to use a matrix to track the path history instead of using a tree. The reason we're switching to a matrix is it'll be easier for you to program when you have to implement your version of breadth first search. So we're using a matrix instead of a tree. The matrix stores the same information as the tree, but it's just easier to program. And let's take a look at how this is different. So on the right-hand side, we have a tree going from the 0, 0 to 1, 0 and 0, 1. That's going to look something like this instead. We have a matrix. Because we have a maze, this works out. The predecessor from -1, or from the 0, 0 location is -1, -1, which means it's the starting location. After that, we see that we got to the position 1, 0 by coming from 0, 0, and we got to the position 0, 1 by way of 0, 0. So this is the value inside the matrix location or the matrix cell is telling you where we came from. First thing this process should do is initialize the various variables. And so we are going to start from the current of 0, 0. The prior location of 0, 0 is -1, -1. And we will add -1, -1 to the matrix for where we came from 0, 0, and then add 0, 0 to the queue, and then mark visited 0, 0 as true. So the next thing we'll do is we pop 0, 0 from the queue and it becomes the prior location. The current location are any possible places that we can go from 0, 0. We can't go south in this case. The first place we look at is to the west. So we mark 1, 0 as coming from 0, 0. We mark the current location as the current location is 1, 0. And then we set 1, 0 in the queue and we mark 1, 0 as visited. Next, we pop 1, 0 from the queue, which means it goes into the prior location. From this prior location, we will be able to search two different directions. The first one to the west is 2, 0. So 2, 0 is our currently explored location. And at 2, 0, we mark where we came from. We add it to the queue and we set visited as true for that location. Next, we explore 1, 1, which is south. To get to 1, 1, the prior location is still 1, 0. We add 1, 1 to the queue and we set true at 1, 1 for visited. Next, we remove 2, 0 from the queue, so that becomes our prior location. We'll see what directions we can search. We can't go down because of the wall, but we can go west. So we'll look at west, and that's the position of 3, 0. 3, 0 came from 2, 0. We add 3, 0 to the queue, and we mark 3, 0 as visited. We pop 1, 1 from the queue and set it to the prior location. From 1, 1, we can get to 1, 2 that has not been visited. East and west are both blocked because they're walls. So we push 1, 2 onto the queue and we mark 1, 2 as visited, and we set the location we got to 1, 2 from as 1, 1. Next, we pop 3, 0 from the queue. 3, 0 becomes the prior location. And then we look at the current location of 3, 1 right here. 3, 1 came from 3, 0. We add 3, 1 to the queue, and 3, 1, we mark 3, 1 as visited. Next, we're going to look at the prior location of 1, 2. 1, 2. And there are three possibilities from 1, 2, and we'll go through each of them in turn, starting with east. So we look at east over here, and we mark 1, 2 as where we came from as our prior location, and we set visited to true. and we add 0, 2 to the queue. Next, we will look at 2, 2 to the west. 2, 2 is here, and we mark 1, 2 as where we came from to get to 2, 2. And then we add 2, 2 to the queue. Last, we look at 1, 3. 1, 3 is here. We say we got there from traveling from 1, 2, and we mark 1, 3 as visited. Next, we pop 3, 1 from the queue. So we're over here. Unfortunately, the only potential direction that we can go is north, but we've already been there. So we're done with 3, 1. We'll look at 0, 2. 0, 2 is here. It's either a prior location to the west, south and north are both 1s, so we don't do anything with that. Next, we look at 2, 2 as our prior location, which is right here. And we can go south to 2, 3. So 2, 3 is our current. We'll add 2, 3 to the queue. We'll mark the location 2, 3 as originating from 2, 2, and we'll mark visited as true. Next, we will pop 1, 3 from the queue, which puts us here. However, there's not a direction that we can go that isn't a direction that we've already marked that location. So we'll skip that. And we will pop 2, 3 from the queue. Explore 3, 3 as a possibility. So we will mark 2, 3 as where we came from when traveling to 3, 3. We will put 3, 3 on the queue and we'll mark 3, 3 as true. 3, 3 equals end. Now what we need to do is we need to build our path back, traveling back through. We will start from the ending location, which is 3, 3, or the current, and then we will rebuild the path back to start. We only need this matrix at this point. Each cell, as we've been doing, points back to where it came from. So we came from 2, 3. To get to 3, 3, we came from 2, 3, which is over here. So which direction we traveled here is west. So starting at 3, 3, we're going to go back to 2, 3. And the direction that we traveled to get from 2, 3 to 3, 3 was west. To calculate this, we can subtract the 2x and the from x and the 2y and the from y. So in the moves array, if we were to look, there's an array. The position 1, 0 equates to west. This is basically saying that we added 1 to x, which is the equivalent of west. To get from 2, 3 to 3, 3, we traveled west. Next, how did we get from 2, 2 to 2, 3? We went south. To get from 1, 2 to 2, 2, so 1, 2 to 2, 2, we traveled west. To get from 1, 1 to 1, 2, we traveled south. To get from 1, 0 to 1, 1, we traveled south. And to get from 0, 0 to 1, 0, we traveled west. So we ended up with west, south, south, west, south, west, but we built it in reverse, so we have to reverse that. And that's it for this video.